To solve this root equation, what we'd like to do is get rid of the square root. And this can be done simply by squaring both sides. Because on the left, squaring a square root just leaves us with x plus 21, whereas on the right, don't forget when you square this, you get x squared, you get 1 squared, but you get 2 middle terms as well. So just a reminder off to the side. When you say x plus 1 squared, you really mean x plus 1 times x plus 1. So you have to FOIL x squared, you get a 1x, you get another x, and then 1 times 1 is 1. So at least the square root is gone from the equation. I'm now going to set this equal to 0 by subtracting x from both sides, as well as subtracting 21. And this changes the equation to 0 is equal to x squared plus x minus 20. Okay, this factors, well, you could use the quadratic formula if you wanted to, but this one's simple enough to break into 2 pieces. It has to be an x and an x, a positive and a negative, positive 5 and negative 4 multiplied to negative 20, yet add to positive 1. This means my 2 solutions are x is equal to negative 5 as well as x is equal to positive 4. Unfortunately, if you take this value and plug it into the original equation, it does not make the left side equal the right. It is possible that you'll get an extraneous solution, which this one is, so we throw it away. That means the only solution to this equation is 4. You can check this by putting 4 into all the x's and making sure the left side is equal to the right. A good place to start this problem is to put this function into your graphing calculator, just being careful to use parentheses around both the numerator and the denominator. And parts A through D are leading us through this question, and part A is asking, what are the intercepts and asymptotes? So below here, I'm going to write down, well, there's probably a vertical asymptote as well as a horizontal asymptote. And then we have X-intercepts and also Y-intercepts as well. So to figure out what these are, I'm going to take my original function and factor the numerator and the denominator. I'm going to put that right up here. All right, this thing hopefully factors. Okay, the numerator, it's going to be x times x. I think that's a positive 2 and a negative 1. The product is negative 2, and they sum to a positive 1. In the denominator, it's going to be x plus 6 and x minus 5. This factorization will help us determine some of these key features on the graph. Starting with the vertical asymptotes, that's where the denominator is equal to 0. That is, x is equal to negative 6, as well as x is equal to positive 5. I'm going to put those on the graph. 1, 2, 3, 4, 5. We're going to have a vertical break in the graph, as well as at negative 1, 2, 3, 4, 5, negative 6. All right, the horizontal asymptote comes from the ratio of the numbers in front of the highest powered x terms. Since they're both 1, you could write 1 over 1, but this is simply just y is equal to 1. That's this value here. The x-intercepts, this occurs where the numerator is equal to 0, so negative 2 and positive 1 are the numbers that make the numerator 0. So negative 2, 0, as well as 1, 0. That is here and here. You can get an exact value for the y-intercept by putting 0 into all of the x's, and that leaves us with the two numbers at the end of the function, which is negative 2 over negative 30. And you could leave it just as that. Of course, this simplifies to 0 over positive 1/15. The only real important thing is that it's some positive number and is greater than 0. Pretty close to 0, though. Part B is asking, okay, does this function cross the horizontal asymptote? So we've addressed part A, that's all of this stuff here. But for part B, I'm going to take my function and I'm going to set it equal to the horizontal asymptote. Looks like a difficult equation. However, I'm going to cross multiply this denominator to this side, changing my equation to x squared plus x minus 2 is equal to x squared plus x minus 30. And, well, the x squareds cancel from both sides of the equation, but also so do the x's, and we're left with negative 2 is equal to negative 30, which is false. So the question of, does this function cross the horizontal asymptote? The answer to that question is no, it doesn't. If it did, there would have been a solution to this equation, but we wound up at this false statement. So this is nice. When we go to sketch the graph, it'll never cross over this horizontal line. All this being said, let's sketch a graph of the function. It approaches the asymptotes, it goes through these intercepts, and then over here, the graph should resemble something like this, never crossing the horizontal asymptote. The final question is, can we use this graph to solve an inequality? Where is this function greater than 1? Well, this is y is equal to 1, so it's this piece and this piece where the graph is greater than 1. I'm going to highlight that. So that is this portion of the graph and this portion of the graph. So the ultimate final answer to this question for part D is those two pieces of the graph. I'm just going to record down the x values for them. It's negative infinity to negative 6, but also 5 to positive infinity. And that technically is the final answer to this whole question here. To solve for the inverse of the function in part A, technically the equation is y is equal to the cube root of x plus 5, then plus 2. So to do this, I want to write the inverse, which is x is equal to the cube root of y plus 5 plus 2. And then I'm going to solve this equation for y. So just to point out, this thing is technically the inverse because I switched my x's and my y's. But now I have to solve for y to make it a more convenient equation. I'm going to start by subtracting 2 from both sides of my equation, which gives me x minus 2 is equal to the cube root of y plus 5. I will then cube both sides to get rid of the cube root. On the left, I'm going to leave it as x minus 2 cubed is equal to then y plus 5 on the right. And I have one final step, which is to subtract 5 from both sides of my equation. And this gives me x minus 2 cubed minus 5 is equal to y. I'm going to write my final answer up here as f inverse of x is the function we just came up with, x minus 2 cubed minus 5. Let's try this again for the function in part B, which is g of x. It might be more convenient to write this as y is equal to 3 over x plus 4 minus 2. But really, for my inverse, that's the equation x is equal to 3 over y plus 4 minus 2. So it is this thing here that is the inverse. But I need to, again, solve for y. Well, just like with the last one, I have to get rid of that 2, so I'm going to add it to both sides of my equation. This gives me x plus 2 is equal to 3 over y plus 4. And now I have to get that y out of the denominator. What I'm going to do is multiply both sides by y plus 4, and I'll write it as over 1. So I'm doing that to this side as well. What this does is change my equation. I'll use parentheses, but we have y plus 4 times x plus 2. I don't need the over 1 because there's no fraction that remains. And on the right, the the denominator here cancels with this denominator there, leaving me with just 1's, or simply just the number 3. The next step is going to be divide both sides by x plus 2. I'm doing this because it'll cancel it on the left, leaving it only on the right. So if I continue my work over here, I don't need the parentheses anymore, but I have y plus 4 is equal to 3 over, again, I don't need the parentheses, so I'll put x plus 2. if I simply subtract 4 from both sides of my equation, I arrive at my answer of y is equal to 3 over x plus 2, then minus 4. This is what we mean by the inverse of the function g. So g inverse of x is 3 over x plus 2, then minus 4. For question 4, we have two polynomials that we'd like to factor by using the graphs. So I started in part A by putting this in place of y1, and I'm going to sketch the thing I see on my graphing calculator. All right, so the graph I see comes up like this, drops back down before then going back up. To answer this question, what I need to know is this spot, and this spot, and those are called the zeros, which I'm going to try to figure out by looking at my table. I mean, it kind of looks like it's -2, 1, and 3. And if I go to my table and type in those numbers, they're correct. It makes all of this equal to 0. So this problem is almost over at this point. All I need to do is just write down the corresponding factors for those 3 zeros. If -2 is a 0, it's because x plus 2 is a factor, right? If you put -2 in place of x, -2 plus 2 is 0. Likewise, this is going to be x minus 1, because if you put 1 in place of x, it makes it 0. So the same thing holds true for 3. If it's a 0, then x minus 3 is a factor. This essentially completes the problem. This thing is x plus 2 times x minus 1 times x minus 3. The product of those 3 factors is the same thing as my original equation. Now for part B, it's definitely a more complicated function. I'll try to sketch what I see. The unfortunate thing is this thing sort of disappears off the screen on me a little bit. Like when I graphed it, it came up like this. I know it eventually has to come back down, so it comes down like this. Again, it disappears off the screen. I know it comes back up, and I see something like this. And the only one that looks obvious to me is this. This 0 looks like it is at -6. But the next one over here, it's something between 0 and -1. And then the one on the right, it's past 2, but it's less than 3. So at this point, I'm not 100% on what those two numbers are. But to start with, if I want to factor this thing, I have to find the zeros. I'm just going to go to my table and check to make sure that -6 works. And it does. Great. I just need to find the other 2. Now, what I showed you in class is if you take this number 30 and you write down its factors of 1, 2, 3, 5, 6, 10, and 30, as well as the factors of the 4, which are 1, 2, and 4, the only things that you should try guessing as fractions are these as numerators and then these as denominators. So, I mean, it's still a lot of options for the 30, but at least for the denominator, there's only so many things that are going to work for, let's say, this value here. This is between 0 and -1. So a possible choice would be something like, maybe -1/2 or -1/4, or maybe even -3/4. I just have to pick a number that's a fraction between 0 and -1. I think an obvious choice would be 1/2, and I'll make it negative. So I'm going to try that. I'm going to type in -1/2. And it worked. You might have to, try more if you don't get it right on the first try, but that's okay. I mean, there's only so many things that could possibly work. So, all right, I need to figure out what this last 0 is over here, and it's between 2 and 3. If I look over here, it's going to be a positive number, a fraction. Maybe it's going to be something like, 3/2 or 5/4 or 5/2 or something like that. So I'm going to try 3/2. 3 divided by 2. And it gave me -60, which is no good, so that did not work. So, I'll try again. Well, what about 5 divided by 2? Let me try that. This one does work. Okay. So if I try 5 over 2, that is a 0 of the equation. So it's at this point where, like, okay, I know the factors. It's got to be x plus 6, because negative 6 makes it 0. For this one, I have to be a little bit clever. It's got to be plus, and a 1 is going to go at the end, but I put the denominator, the 2, in front of the x. Negative 1/2 makes that factor 0. And likewise, okay, it's got to be x minus 2, but since there's a, that's not correct, that's x minus 5, and since there is a 2 in the denominator, that goes in front of the x. This means my equation factors as x plus 6, 2x plus 1, and 2x minus 5. Now, that is the answer to this problem, but just be careful. If I multiply the coefficients here together, it should multiply to the 4. It does. 1 times 2 times 2 is 4. And if I multiply the numbers at the end, it should multiply to negative 30. So it's 6 times 1 times negative 5 is negative 30. So this is my answer. For question 5, we have this graph that we're going to transform in 2 different ways. For this problem, I'm going to write out the path that each of these 3 points will take when you run it through this function. So for starters, this function does 2 things. I see we're multiplying by 2, and then there's this minus 8. In terms of order of operation, you would work within the parentheses first of the function, and we're subtracting. And you might think this goes left 8, but when you change your x's, it's always the opposite, so that's going to be right 8 places. The second thing this function does is multiply by 2. That's outside of the function, so we're changing the y values, and that's going to do exactly what you think. It's going to double the y's. So with those 2 things, I'm going to move these 3 points through those 2 steps. Okay, starting with this point here, okay, we're going to go right 8 places, so that's 5, 6, 7, 8. Now I'm going to double the y value of 0, but if the y value is currently 0 and you multiply by 2, it stays 0. This point moved here, so let me mark that down. So likewise, this point is going to move 8 places to the right from 0 to 8. The y value is currently at 5, and if I double it, it goes to 10. So that new point is 8, 10. And lastly, I have this point at 3 for x. If it goes 8 places to the right, we end up at 11. The y value is 5, and if we double it, it goes from 5 up to 10. When all is said and done, this is my function. It went right 8 places, and then we doubled the y values. For my other function, again, it's just a 2-step process here. We are not changing the x's, we're only changing the y values, and we're going to multiply before we subtract. If we multiply the y values by negative 1, this is a reflection. I'll write this as reflect over the x-axis. And then the minus 2 means you go down 2. Starting with this point, that negative 1 means multiply by negative 1. But if you multiply 0 by negative 1, nothing happens to it. If you then go down 2 places, this is the final location of that point. So I'll mark that here. Next, I take this point and I multiply by negative 1. We're multiplying the y value by negative 1, so it goes to negative 5. And if I subtract 2 more, it goes to negative 7. And lastly, this point, if I multiply the y value by negative 1, it goes to negative 5, and subtracting 2 more takes me to negative 7, which is right here. And then this is the resulting graph. It was reflected over the x-axis, and then the whole thing went down 2 more places. I started this problem by defining my variable. I'm going to add some number of liters of an 80% acid solution to 2 liters of a 15% acid solution to increase the concentration to 75% acid. So I'm expecting to be quite a bit. Our approach is to set up an equation. On one side, it's going to be what we actually mix together, how much acid we're mixing together, and on the other side of my equation is what we're going to end up with. So this question is phrased as, how many liters of an 80% acid solution, so that would be this. That's the amount of acid being contributed by the 80% acid solution. We're mixing this, we're adding it to 2 liters of a 15% acid solution, and we want the result. Notice again that this is 2 separate pieces because we're mixing 2 things together. On the other side of my equation, I want it to be just one term. It's going to be a percent times an amount. I want it to be 75% acid, and the amount is going to be 2 plus x. The goal is to now solve this equation. So let's quickly go through that. I really can just write this as 0.8x, and then if I do 0.15 times 2, that's 0.3. On the right, I'm going to distribute the 0.75, and I get, 0.75x plus 1.5. I will subtract 0.75x from both sides, and also I'll subtract 0.3 from both sides, and I get 0.05x is equal to 1.2. If I divide both sides by 0.05, this gives me my answer. 1.2 divided by 0.05, 24 liters of an 80% acid solution.